Okay, we're up and running. Do you have anything, do you want to mention anything you've been looking at?
Well, I mean, I looked at this as radio control car. I thought it was an interesting platform. It is a Hot Wheels monster truck 1-to-10 ratio. As a winter project, but didn't pull the trigger on actually buying it because Jeff told me I couldn't buy another platform without getting my first platform working. So
I'm just saying, don't buy some expensive thing that you think is going to solve all of your problems, because that's just another headache. Even though they say it's ready to go, maybe it is, maybe it's not. So,
oh, by the way, I wasn't sharing my screen, but anyway, it was this this Hot Wheels monster truck shark fin, I think was the or shark, tiger shark. There it is, tiger shark. And Jeff was just commenting that it could have a solid axle in the back and not be very conducive to actually getting, sensors on it to actually get, all of that output out of it that would make it useful. But it sure did look like the good price point for playing around with it. But anyway, I better focus on what I've got going. And back to the lawn tractor.
and the 1/10 scale probably be a nice size too for playing around. It's not too small where you can't put computers and sensors and stuff on it. It's not big enough you have to muscle it around. So that might be a reasonable size to carry around. Just put a handle on top, you can carry it around.
Yeah, that's what was initially intriguing. Back to the lawn tractor. So the reason I was in Walmart in the first place was to buy a battery for my lawn tractor. I was able to, I had to directly connect my laptop to download updated transmission control software to the Teensy that's embedded in the Super Servo. So in the process of getting that done, which took me a bit to do, because there was some getting the compiler resolved. I mean, I had previously used an over-the-air tool to download that, and getting it working with my laptop was more of a pain than I was expecting. So spent way too much time making that work. But finally got that working, and then when I was ready to actually get outside and test it, seems like every season I lose a battery, and so had to make a trip to go get a new battery for the lawn tractor. So yeah, so I'm ready back now to test the new transmission control software that's on the Super Servo. So that's where I'm at, and I'm hoping to get back out and do speed testing, and so I can then, process steps for me, test speed sensing and get the speed under, more precise control, and then use the code that Jeff had put together to, I'm going to get the language, I think, wrong, but to do a hard left and a hard right and get the, I'm going to call it rotational velocity, but I think you call it something else, Jeff. You had used my data and suggested it was like 0.88, and then use that value and hard code that into my low level steering control as the leftmost range or rightmost range. So I know what I need to do. I'm not using the right language probably, but anyway, those are the next few steps for me to do with my lawn tractor. Hopefully all before the snow starts flying.
Now,
That's it.
if you would have waited to buy your battery till next spring, that you wouldn't have to buy a new battery next year. But if you're ready to
Yeah.
test, I guess you got to go do it.
I think it was $30, so it's a donation to the cause. Hopefully I'll be able to keep it through the winter. It shouldn't be that hard. Keep it on a trickle charger, bring it inside, keep it warm.
That's probably the best thing, is to take it inside. And I don't take mine out. I'm too lazy to go out and get it. But now you mentioned it, I might think about that. But mine, I think, has been in my mind for like 2 years now, and I've driven it about 10 minutes in that full time. So I really should go take mine out.
That's what's frustrating, is I've got like hardly any time on the darn thing, but they just don't last. Anyway.
So what
And you've been doing a lot of work with Gazebo.
I haven't been doing a lot of work, but I've been doing enough that I got some results that I can show. So I just posted in the chat the code that I started with, and I kept going back and forth thinking, well, it's way too complicated. And then I looked at other stuff that, well, maybe it's not too complicated. So let me just pull up a screen here and try to get something to work.
GitLab. I'm not familiar with GitLab.
Oh, that might just be where somebody goes around and copies other people's, these companies will go through and find all the GitHub stuff and then post it as a list, or they'll say, oh, here's all the open source stuff. So they just scrape the web and put it all in one spot so they can get hits on this stuff. It is nice to have indexes and stuff. Anyway, I didn't really, when I looked at it, I didn't really pay attention to who it was from. It's just that I started with the code a couple of years ago, and just now when I searched and it showed up here. So it could be this isn't the official. He may have a real GitHub somewhere. I haven't looked at that. So let's see if I do this screen sharing. Now let's clear that. Okay. And this may be awfully slow, but we'll see what happens here. So basically, when you pull this code up, there's like 2 launch files. One is a launch file for the description, and the description is what builds the model in Gazebo. And then there's a second launch file that starts the first one and actually starts up Gazebo and does a few other things. So basically, if I come here, and I think right now here, let's look and see. So right now I've got my URDF in there. So these are the values for my down here. It's handy having 2 screens so I can see the delay happening. But see down here, here, let's use this pointer. So I got 2 pointers too. So right here, I've got my URDF file that I've hacked on. I took the original one and ripped out the shock absorbers, ripped out the batteries, and changed the wheel sizes. I can get into more on that later. But anyway, that's the one that's in there right now. So if I come back to here and launch it, we'll see if it works. So there is my version of my mini tractor. And
Awesome.
if you look at it hard enough, you can see if I drag it around, let's see if I do this. This one. See if I do like this and put it in the middle of one of those squares, then we go look at it. Let's see, you got to do like this to rotate. It's like everything else. It takes forever to figure out how to orient this stuff. Well, anyway, the point was I wanted to say that these squares are 1 meter squares, the grid on the ground. So mine is not quite 1 meter long, and it's maybe 3/4 of a meter wide is what my vehicle looks like. Let's zoom back out here and turn that off. And then down here is a file that says it just publishes an Ackerman message, and right now it's set to 1/2 meter. Down here it says speed is 0.5 meters per second, and then over here where it says steer angle is 0.5 radians. So it'll publish those 2 values out. And when I started here, it didn't do anything. There we go.
Holy cow.
So you can see it is actually driving around. And when I pull up the next one, you'll see that the wheels aren't real stable. The wheels will kind of jitter back and forth. But so at that point, if I come down here and say Control C, and then change the steering to say 0.3, so you can see how it was driving in a circle right there. You can see on the screen. If I just give it a shallower steering angle, now it's going to drive in a bigger circle. And if I'd load up an Ackerman joystick program, I could sit here with a joystick and actually drive it around. Now, at least I see no reason why I couldn't do that.
Can you do a Ross topic list?
And being Gazebo, it's got lots of stuff. This is all your joints and your tires and all that stuff at the top here. Everything says Ackerman vehicle. This is all the wheels and all the stuff associated with the wheels. And then down here, link states is something interesting. You can subscribe to that, and it says for each joint that you have, it tells you, it publishes information on that. So in order to get the odometry to work, this other guy's code that I found, he will subscribe to this link states, and he says search for the entry called base link, because it's just an array of all these things. And then under base link, it's got a standard like a pose information there. So it tells you your XYZ and your I think it tells you your rotation, your 3 rotation values. And he just took those values and stuck them into odometry message and publishes that. And I don't have that running right now. That's just another program I can start up. So it goes out to Gazebo. It takes a standard Gazebo thing and prints a odometry message for base link is what it's doing. And the rest of this is, again, this is all wheel stuff down here. And the only thing really, let's see, where is it? Somewhere there's an Ackerman message. It might be at the top, very top here. Ackerman command, the very first one here. That's the one that's being published. That's telling it how fast to drive and what steering angle to use. So in general, you know, you start up Gazebo and you get lots of junk here. So and pretty much I ignore it until I need to know something, and then I can go look at those things. So here the vehicle's still driving around, as I say, it's driving in a bigger circle. So we'll come down here and we'll stop the let's get rid of it. Let's see, go to this one, Control C. When I do that, then the vehicle comes to a stop. So I'll kill this one. And then I will go back into here. And I'll say use Al's code, Al's vehicle. We'll save that. Now don't be alarmed when it starts up, it bounces. It's hard to see because it's got that logo shows up, that icon. But see, it fell and it bounced, and I haven't really figured out. Now see, it might be right side up or upside down. So what we can do is we can click on this thing and look at it and know it's right side up. So it's where it's supposed to be. So let's turn that back off and come down. Let me zoom out a little bit. And let me. Now, one of the things that's frustrating is the mouse buttons between RViz and Gazebo, like the rotate and the move, or backwards or something. So it takes a lot of playing around to get this stuff to work. I've been doing all this work with Gazebo, so RViz hasn't really confused me here. So we'll give it the half a meter per second speed, and we'll give it half a radian for steering angle, and I'll say go. And there is Al's vehicle driving around.
That's awesome.
And I took the values you sent me, and I found a web page that said, well, no, your tire diameters are really 20 inches and 15 inches, as opposed to, I think he said 22 and 18 or something.
Yeah.
So I changed those, and otherwise most of these values are the same as what you told me. So I don't know if that actually looks like your vehicle or not. And I didn't put anything other. The main thing is just the tires that I put on here. So the tires are defined and they're driving and what's controlling the thing. And this white thing in the middle is just simply something called chassis that was in the original stuff. And for mine, that's so mine has basically that's my main body, and then my tires are right on the so the tires are right on the back and the front of that. I guess we didn't look at that while I had it up, but that's what that's telling you. And
I mean, for everything that I need, I mean, what you have there is perfectly fine. I mean, holy cow.
And since I ripped all the shock absorbers out, there is no suspension on this right now. So it's a completely rigid frame. So if I put this on, put on a non-flat surface, so we'll say insert, let's see, asphalt plane. I'm going to pull up the Apollo 15 landing site, if I can find it. There it is. I can never make this work.
Would it get hung up on the rocks?
I'm thinking of the fact that the ground is not flat. It's going to, since the frame is rigid, you won't have 4 contact points all the time. Well, it's thinking here. It's trying to do something. So we'll see if this comes up. So originally it had shock absorbers on all 4 wheels. So all 4 wheels could independently move up and down. So it would be compliant with the ground.
What's unclear to me, Jeff, is how does this platform or gazebo, how do you implement something like this in the physical world? What runs on the RPi on the, on the robot versus, in the simulated world, you've got all the horsepower you need with your laptop.
Well, no matter what you're doing, you need to have a clean dividing line between your simulation and everything else, all your navigation stuff for your robot. And that's true whether you're running Gazebo simulator or stage simulator. You really have to keep those 2 separate. Now I know this stage simulator, it looks like this isn't going to go anywhere, so apparently it's crashed. So I'll just go ahead and kill this for now. And then let me try to get back to where my train of thought was. So you need to keep them separate, where you've got a simulator, and then the simulator, you want to feed it commands to tell it to move. So in this case, it's using an Ackerman command message, and the stage simulator is using the modified command velocity message. And if you wanted to, you could modify stuff so you could use the original command velocity message. And any one of those, you feed in the information to tell it. Basically, you tell it how you want the vehicle to drive around, and then the simulator takes over and drives wherever you tell it to go. Now, at the same time, the simulator can generate information coming back out. So I was saying you can generate wheel odometry. He's got a trick to do that.
This person that you found, did they, how many sensors did they integrate? Did they get to a GPS?
Well, we'll get to that in a second. So once you define your vehicle and you get a slow drive around, then you can start adding sensors on. And Gazebo has a pile of stuff. You just grab somebody's code, you drop it in, and you can do a simulated GPS. You can do a simulated IMU. There's sonar. You can put on LiDAR. There's various things that it's been around long enough, and you just go out and search for it and grab somebody's code and drop in there. You have to change a couple of things to make the names line up, but in general, you can mix and match. So whatever you want on your simulated vehicle, you can do that. So one option is if you've got a lawn tractor and it has, say, a GPS and an IMU, then it makes sense to go to your simulator and put on a GPS and an IMU. So it matches. And the whole point of this, of simulating, is you want it to work like your vehicle you have. Or if you're thinking about buying, say, a laser scanner someday, you could put that on your simulator and then get it all working there and say, okay, now I'm going to shell out the money for some kind of a laser scanner, anywhere between $100 to $20,000, depending which one you want to put on there. And so it's just a matter of number one, my theory is you want to make the two match fairly closely. And now you're asking about where's the dividing line, or if you're going to run this on a real vehicle. Well, if you run a real vehicle, you don't have the simulator at all. So that simulator would be completely out of the picture. So now your navigation software says, here's a command message, whether it's Ackerman command or some form of command velocity message. Your navigation software puts that out, and your navigation software doesn't know if you're running on a simulator or running on a real vehicle. It's up to you on your real vehicle to intercept that message and do something with that. And you have that right now. And likewise, the rest of the stuff, as far as sensors, if you're running the simulated world and you turn on GPS and IMU and all this stuff, it will automatically be publishing this stuff and goes across this imaginary dividing line from the simulated world into ROS topics. And those are the same things. If you have an actual vehicle, then you would have a GPS and an IMU, and those are publishing directly to ROS topics. So again, your navigation software doesn't know if you have a physical vehicle or a simulated vehicle. So the original question was, well, what about all the extra horsepower to run the simulator if you had a real vehicle? Well, if you have a real vehicle, you're not running the simulator. So that's totally out of the picture at that point. But it should be the point where I could start this up and say, start it up and talk to the simulator. I can go drive it around, or I can say, start it up and talk to the real vehicle, and then you can drive your real vehicle around. Now there's another slight confusion there, because see, normally what I would do if I'm going to do a simulated vehicle, I'm going to put all my navigation software onto my laptop and put this simulator on the laptop and start it all up there and drive it in one piece. Whereas if you go to a physical vehicle, then you're going to load your navigation software on your local computer there, which you have a Raspberry Pi, and I would have a laptop on mine. And then it talks to whatever low-level controllers are doing the actual functionality. So as far as trying to get the simulator to run on your real vehicle, well, the point is you don't do that. You run one or the other. You run your physical vehicle or you run the simulated vehicle, is my thoughts on that. And if you keep the dividing line defined well enough, then your navigation software doesn't have to know which one you're running. Now it gets a little trickier, because if you're running on the simulator, I would say launch that model we just saw, and as part of that model, it would have GPS and IMU and all this other stuff. And then I have to run a separate program to generate odometry from that. So basically, I would have a launch file for the simulator that says start Gazebo. It would say load my physical or load my simulated vehicle into the world. And as part of that simulated vehicle in the URDF file, it's got the sensors already built in. So this thing is then automatically listening to some kind of command velocity message, and it's automatically publishing the topics for whatever sensors I happen to have. Now, so basically I would have one launch file that's the simulated stuff, and then another launch file that's all my robot navigation stuff, and then a main launch file that says, I want to run a simulated vehicle. So it would say, start up the simulator launch file and start up the navigation launch file. And it will run that way. And the navigation doesn't know that I'm running in a simulated world. Now, on the other hand, I would have a launch file for your physical vehicle that says, here's how you talk to your steering controller and how you talk to your transmission controller. You said start up all the nodes to do that. And they would, as soon as you start that launch file, it would listen to whatever the topics are. And so again, that stuff is separate. That's the same stuff there that you would have over here on your simulator. So the simulator, you start up that launch file, it accepts commands and publishes sensor data, or you start up the one on your vehicle. And again, that listens for movement commands and publishes whatever sensors you have. So now these two are interchangeable. You run one or you run the other. And then down below you have your launch file that runs all your navigation and whatever you want your robot to do. And whether I was running the stage simulator or the Gazebo simulator, essentially either one, you have to tell it, you have to feed it the motion commands, and then whatever sensors it has or whatever sensors it's generating, whether they're real sensors or you fake something out, you want to keep all that separate in its own little block over there. This would probably make more sense when I get to the point I can say, here's a demo. I fire up this launch file. It starts this launch file, this launch file, this launch file, and look at that. It drives around, and then be able to say, okay, shut all that down, and say start the other launch file, which will start up. So, again, start up the core navigation stuff, and then start up all the stuff to talk to the vehicle. So just by having two launch files, you say run the simulated world or run the real world, and then it starts up the appropriate stuff to make it happen.
No, it all makes sense. I'm just what you have. I was just poking around this guy's website to see. I was trying to see if I could figure out how many sensors he had integrated, and I really couldn't.
Well, you'll find that let me look at that website for a second here. Yeah, so since this is not a real GitHub, you have to go track down.
And I was trying to see in the URDF if there was how many joints there were, but I didn't see an IMU or anything in there. There was a battery. And
I think if you scroll down to the bottom of that URDF file, you'll find that he's got, I think it's a camera. He's got a camera on it right now. And there's, like 20 to 40 lines of code that says, here's a camera, here's how we define it, here's where we place it. But the sensors are pretty much universal. When you're running Gazebo, you say, give me a GPS, and you drop in the chunk of code into your URDF file for that, at which point you say, there's basically two sections of code for each one of those. The first section is defining the object on the vehicle that'll show up on the screen. So I can say, give me a GPS. I say either want it to be a cube or a sphere, or I might just do a short cylinder to look like those survey grade antennas. And let me clear this other screen here. It keeps bothering me. So one section is showing what the thing physically looks like, how you want it to show up on your Gazebo screen. And then also that's where you put your origin to tell it where to place it on the vehicle. And then there's a second chunk of code that says, we want to load this ROS controller. And I think when you run GPS, I think you go out and you get the Hector GPS is the one that everybody uses. And under that, you tell it the library to use, and you tell it what topics you want to publish on and various things. So no matter what kind of sensor you have, whether it's a camera or a GPS or an IMU, the first chunk of code says, here's what it's going to look like, and this is where it's placed on the vehicle. And the second chunk of code under there says, I want to use this communication library, and these are the topics in and out. And like, for instance, on a LiDAR, you can load up the Hokuyo, I think is what everybody uses. And you could either use, people typically have a little picture of what that looks like. And I think they actually have a mesh for that. So somebody went into a CAD program and made a fancy looking little box for one of those. So that's what it displays on the screen. Or you could put a cube, or you could put a sphere, and that just shows where it's at on the screen. And then under the control section, you can say, how many degrees do you want to scan? So regardless of what the thing is called, see, my scanner does 180 degree scan for my old SICK LMS 200. So you can go in there and you can say you want it to scan 180 degrees, and you can give it like a maximum range and possibly a publish rate. So I could tailor it to the sensor I have, or if you have the actual Hokuyo sensor, I believe that one is 270 degrees, and it probably scans twice as fast as mine. And I don't know what the range on it is, but by just manipulating those numbers, you just take the generic laser scanner and then modify the numbers to fit what it is you happen to have. So if you got one of those cheap little ones like the, let's see, yeah, okay, I have to remember, okay, that probably showed up full screen. This is the little laser scanner out of the vacuum cleaners. And you can buy these on eBay for like $80 to $100, and then you have to get a little motor controller to put on it. But this one will do a 360 degree scan, and it's only got a range of like, I don't know, two meters or something. So again, you can just tailor these things to simulate what you want it to look like. So on your vehicle, you put a physical thing that you go out and you purchase and you bolt it on there, and it's got certain specs for it already. But you can go into the simulator and say load in a GPS module, or in this case, load in a LiDAR module, and then set all the parameters so it acts approximately like your sensor you want to put on. So once you get the vehicle moving, then you start grabbing sensors and dropping into the code, and then you have to fight with it for a little bit to get all the names to match and all the stuff to work. But it's not really that hard to do once you get that far.
I guess I'm thinking this Gazebo. I mean, I just went over and started looking at navigation, and it starts referring to, I mean, I'm just on ross.org navigation, and it literally is referring to navigation with Gazebo. I'm like, what? The Gazebo is a simulator.
And you're right, Gazebo is just a simulator. It has nothing to do with navigation. Navigation is on the other side of that imaginary dividing line, and your navigation all runs under ROS. It says, where am I? Where do I want to be? I need to drive this direction. And the simulator just takes that stuff in and moves stuff around in its simulated world. So no, the Gazebo has nothing to do with navigation. It's just simply it's representing your vehicle. So if you've got navigation running under ROS, whether it's talking to your physical vehicle or talking to the simulator, then the fact that you've got the navigation software talking to something that's actually moving around, then it all ties together, and then everybody's happy if you've got it all set up correctly. So don't read too much into, they say it's the simulator. Well, that's what it does. It simulates it. It puts a vehicle, you can tell it to move and it will. It can see objects out in its world. It sends that stuff back over topics across this imaginary dividing line you have. And like on your lawn tractor, you still got that imaginary dividing line where you've got, on one side, you've got ROS running your navigation stuff, and the other side is all your physical stuff on your vehicle. And you've got multiple, in your case, you've got multiple launch files or multiple nodes where you've got like the ROS serial nodes, one for each module you got out there. So all that starting up of all that stuff would go into your starting of the physical vehicle, and then all that stuff is done slightly differently. And then for the simulator, and your simulator launch file, it starts up the pieces for it. And now, yes. See, since you just brought up that picture, let me point out, this is a conceptual view of the entire thing. They don't say this is done here, this is done there. So it can be a little confusing when they post something like this and say, yep, if you got everything tied together, it'll work. So on this particular one where it says odometry source and it says sensor sources, those kind of blue ones there, those are physically coming from either the simulator. In the case of sensor sources, that's either physically coming from the simulator or physically coming from your actual sensors. But they don't point that out here, that, well, you have to figure out where this stuff comes and goes. So that,
no, I get that.
That's why these diagrams are a little deceptive.
You mean move base or move base flex? I mean, my question is more about, I mean, this shows move base, and I think at the moment, move base flex is what is firing up in my, when I do, I think move base flex is what's firing up for me at the moment.
I believe that's true.
And when you did a ROS topic list, I didn't see any any move base related.
There's a good reason for that. I'm not running move base. All I'm running is I'm running the simulator, and I'm running a single command line that says publish this Ackerman message. So I don't have any of the navigation software running at all at this point.
Which is, I was just interested to see how much of the, the total stack was, getting fired up, so to speak. So that's all to be added later, obviously.
Yes,
So that,
I will say, yes, that is true.
I mean, that helps. And then your because you have a URDF defined, I'm assuming your transforms are all, well, they wouldn't all be set yet because you don't have all your sensors organized yet, right?
Basically, any transforms that are set are there because they are needed. So yes, I don't have any transform for, say, GPS to anything else or IMU to anything else because I don't have those sensors. Now there are 2 or 3 transforms buried down in this URDF file that has something to do with how the Gazebo model works, but I have not added anything extra as far as telling it where to put. There is internally, there's a transform between chassis and base link, and then I think there might be base link to something else. And it turns out they're wrong on my model. And I don't know if I just reverse the order of that, because right now it's defining the center of the vehicle is the center between all 4 wheels. And then for some reason, base link is right on top of that. So their base link is on top of the center of the vehicle. And I want to have it on the back where it belongs. But when I tried to do that, something else moved and it didn't work. And I might just have to go the other direction. Instead of saying chassis to base link, I might have to say base link to chassis, and that might solve my problems. But that's just little details. Each time I run into something, I have to figure out how do I get around this and make it work the way either I want to or the way that I know it has to work. So it's just a matter of poking in it.
Out of curiosity, the guy that you found, did you happen to notice, did he ever fool around with move base or move base flex?
The particular one that I've been showing is just the simulator. Now, if you go, like you were pointing out, this is on what called GitLab. Well, if you can find this on GitHub, then it'll tell you where he forked it from and who forked it from him. And some of those, because it's like 80 times. This original package started out and it's been forked 80 times.
Wow.
And if you look down the list, well, it's forked by Droder and by Vinny, and I may have forked it at times. So there's lots of copies of this stuff floating around, and some people have actually beefed it up to the point where it's like a full navigation. You can load the thing up and say go, and it should, as long as you get the right version of ROS, the right version of Gazebo. I've been running into problems with that. That when I first started with this, like 2 years ago, I loaded up a random RC car. I tried to run it. I was complaining about lots of things that didn't like for whatever reason. And I think it was because I had the wrong version of Gazebo or the wrong version of ROS. So I did more searching, and it turns out this almost exact same thing shows up again and again and again. And you get one, and a guy says, oh, well, I've modified this. I've updated it for noetic and melodic and noetic. And the one I have that's running, I'm currently running this under kinetic right now. And my other laptop has noetic loaded on it, and I haven't really done anything on that. But depending when it was written, it may or may not, right out of the box work for you. Because the one I started with would not run under kinetic. And then I found this car with the red wheels, which, here, I was going to put that picture up.
See, I thought you were a Ubuntu 20 guy, and I was surprised to see 1604.
Well, my real laptop has 2004. And speaking of that, I have all kinds of problems with it. If I run every night I put it in suspend before I go to bed, and the next day I just get up, take it out of suspend. And after about a week or so, it'll lock up on me. And then there's other things that I notice are doing stupid things under 2004. So I don't know if it's my computer or if it's the Ubuntu 2004, or if it's something else that's loaded on it. But anyway, I have problems with that. But my robot computer is the kinetic. So here, this picture here, let me share that, share screen. Screen one. So this should be the, let's see, I don't know if those are in the way, I'll move them.
And again, this is Gazebo 7.
This, the one that comes standard with Kinetic is Gazebo 7. And then somebody said, oh, to run my stuff, you should load Gazebo 9. So he said, run like an apt-get remove. He said Gazebo star space Gazebo something else. And when you do that, the first thing that pops up, it says, oh, I'm about to delete ROS desktop full, which means it was going to delete everything that I had loaded for my ROS, which when I say everything, it deletes all the standard binary files. So when you're done, I would not have ROS on that computer at all if I would have done what he told me. Right. And then down below, he says, okay, now I'll say install Gazebo and then install ROS base. So the trick is if you run, if you install desktop full, that gives you all the ROS stuff, including navigation, plus Gazebo, plus some other stuff. And if you just run ROS base, it just gives you the underlying communication stuff. So you get ROS that runs, but you don't get all the fancy desktop stuff that you would normally run. So his point was, well, you say uninstall and it deletes everything. And he says, go back and reinstall ROS with just the base package. And he says, and then you can install your other packages later. So that's not really the way I wanted to go. So I just gave up on installing Gazebo 9. Now, it could be I could just say install Gazebo 9 right on top of Gazebo 7, and it may work. But at this point in my life, I didn't really want to risk doing that. So I didn't. And then if I look at my other computer, it's got Ubuntu 2004 and it's got Foxy, it's got ROS2 Foxy, and it's got ROS1 Noetic loaded on it. That one, as I say, that comes up with Gazebo 11 that's on that one. And there was that dividing line between the old stuff and the new stuff where they changed from the Python versions. So again, poking around at different copies of the stuff you find may or may not work if you just load it and run it. And so let's see, so I wanted to show the screen here. This is what the original one looked like. The one's got the one I posted the link to. If you load that under Kinetic and run it, it gives you this little RC car that's got, for some reason, he put red wheels on it, but that makes it interesting because you can immediately tell which one it is. I put black wheels on the ones I was doing. And the original one had this black thing is the chassis, and then these blue things are batteries. They went to a lot of trouble to define these batteries, I think just simply for weight, so you get correct weight distribution on this thing. So I threw the batteries out completely, and I pulled all the shock absorbers off and tried to do my stuff. So let's see, how do I get back out here now? Stop sharing. Okay, let me move these over out of the way. I need about 6 screens on my computer, I think. That would probably solve all of my problems, I think. So where did we leave off here? I forgot what we were talking about.
Well, I was trying to confirm what version of Gazebo you were running, and you were talking about the different versions and how they sort of fit together.
And on Kinetic, it comes standard with Gazebo 7. If you want to upgrade to Gazebo 9, you're going to have to go track down the instructions so you can do it without destroying your ROS install. But it should be possible to do that. So right now I'm running under a fairly old version of Gazebo, and it seems to be working. And I do have there's an error that comes up and says something about here, let me pull it up so I can read it here. It says something about, it says Gazebo ROS control plugin missing, legacy NS mode, while default robot hardware sim defaults to true. And then it says down below, it says, oh, to fix that, just set legacy node NS to true. Well, I can't figure out either I can't figure out how to do that, or my combination of stuff I'm running doesn't allow that. So I get this error every time I run it, but it still works. So I've just moved past that and just ignored
it. And this Ackerman package only works with Gazebo 7. Is that what you've concluded?
No, as I say, there's like 80 different versions out there, 80 or 88 different forks of this. Some will work on kinetic, some will work on noetic, some will work on melodic, some will work back with very old versions. And they don't always tell you that. So you have to try it and see what it does. But I know the one I've got, the one I have, and after I've done hacking on it, it works on kinetic. I guess I don't know if you just load this up and run it, it's going to work. I think that one that I did, that picture I showed with the red car, I think that was pretty much, I just cloned the repository and maybe had to do a make and then said run it. And I got a car that moves around on the screen. So I think that version does run with kinetic. And I'm not suggesting somebody take my ramblings here and go and try to duplicate this at this point. You know, hopefully in a short amount of time, I'll have something running well enough. I could say, here's what I did and it works. And then if anybody wants to try to duplicate it, you could.
Well, the notion of having a trimmed down version that you just, you know, that has a simple URDF. You just add move base on top of it, add your sensors. Or move base flex. I think that'd be cool.
And theoretically, this will work, but I'll have to go a little further to see what happens here.
What's really nice about it is, you know, you don't have the fake GPS and you don't have you wouldn't have the, I would say, well, you would have a clean TF because all the transforms would be coming from the URDF, right? If you set up the sensors in the URDF. So it would all be nice and clean.
Oh, yes and no. Yeah, you may be oversimplifying that a little bit or putting too much emphasis on what a clean installation looks like. But yes, if you add a sensor into your URDF file, that will automatically extract out your transform from that. And you still may have a few things, you know, when you go out to do your navigation. So again, we got that clean dividing line where you got all the stuff for the simulator where it's got its simulated sensors and it builds its TF entries there. And then on the other side of the dividing line where you got your navigation stuff over here. And if you had a thing that said, create a transform between map and ODOM of 0, 0, just put them on top of each other if you're just running the GPS, well, you're still going to have that stuff. So it's not, it doesn't automatically fix all of the problems. It's just each little piece, because, you know, ROS is, you know, hundreds of things stuck together and each one has to work right. So it's really just a matter of, yes, you can build the stuff in the simulator. You can put the simulated sensors on there and they will start publishing the stuff, but still there are other things to tie in all this together that may or may not end up being a problem. Not really being a problem. They're just little steps you have to take care of one at a time.
Have you seen a simulated GPS in Gazebo 7?
Yeah, it's just there. You just load it in and say, here's the GPS, and it should start publishing topics of type GPS, but I don't know what the format is. I don't know if it puts out like a navsat fix or if it just puts out a message that says latitude, longitude, altitude, or what it puts out. But yeah, it'll work all the way back to, I think hydro is where people started doing this. And you'll also find when you go to put sensors in, somebody say, oh, well, don't use the standard ROS sensor. Like in this case, don't use the standard ROS GPS sensor. Go out and get the one from the Hector project and use that one instead. I don't know what the differences are, but you'll run into things like that where they say, you know, here's code to do the sensor, you just drop it in, it'll work. But they'll say, well, use this one instead of that one. And I was trying to think, could you just have include files? But I think there's probably enough hacking on each GPS or on each sensor chunk of sensor code that it probably makes sense just cut and paste it right in there and hack it in line to do this. And that's still more things I need to determine if that it makes sense to do it one way or the other.
Well, I better go get my measurements and double check my numbers.
Yeah.
Actually, I looked at it and I think my wheel, the distance, the front wheels are wider than the back wheels, which surprised me as I looked at it. But I didn't measure it as I was walking out the door this morning.
And that is surprising because the number you told me, you said the front end was narrower than the back.
Yeah.
Like on mine's approximately, the front and the back are approximately the same width. And I knew on yours it was somewhat different. But and the other thing to keep in mind, being Ross and Gazebo is part of Ross, that they want everything in meters as opposed to inches. But it's not that big a deal to convert back and forth. So if you got a tape measure out there and if it's got both on, you could write them both down at the same time. Say it's 42 inches, which was 1.07 meters, I think is what that comes out to.
And you're putting that, I mean, is that just a text file that you're putting those in? Well, I mean,
I'm putting that into the URDF file, which is a text file. And let me see, how do I do this? I shut this down. I want to start up my screen sharing again. Go here, go here. Join using your browser. Okay. Say allow. Say join. Okay. See, oh, there's just too many buttons here. Allow that. Join with audio. Join by audio. This better work when I get all done here.
I'm sure it will.
Turn off that. Turn off that. Okay. Okay. Now, if I turn on screen sharing and say select window, entire screen, allow. Let me get rid of this window. So if let's see, the URDF file. Now there's another journey I had to go down here because when I started off, I pulled up their URDF file. And of course, it's got this big, massive license thing on the front. I don't know if I have to leave that or get rid of it. But coming down here, it says, if you're using the Zacro extensions, because you have a URDF, which just has the actual here, I'll show you what URDF looks like. So URDF just looks like this, where it's just got inline code for all this stuff. And it says, here's the, so starting right here, this is defining the left front wheel. So there's like 50 lines of code here that are defining the wheel. And this is all expanded out from the macro. So if you're doing it with the macros, you come in here and you say, he comes down here and says, he originally didn't have the distinction between the front and the back tire. So I added that. So I can say tire front diameter, and I can say tire rear diameter, and you put in the numbers there for what those are. And then the macro stuff down below, let's see, we go clear to the bottom here. And here you say, we're going to define the wheels. So it says, I want a front wheel, and it calls this macro called front wheel. So that
right.
the macro for front wheel, there's rear wheel. So here's the macro for front wheel, and you pass in the LR prefixes. This always confuses me. It's left, LR is left and right. So you're telling if it's the left wheel, the right wheel, and the other one, the LR, or no, the FR is front and rear. So that always confuses me. I have to go dig that up, but it's front and rear and left and right. So you pass it in and say, I want to do I think the first one down there, let's just say we're going to define a front left wheel. So you pass in as a prefix, you say left and you say front. And this reflect is here because you can say, when you define a wheel, first of all, when you define a wheel, you define it as a cylinder, it's laying down flat like that. So somewhere down here, when you say define the wheel, you say rotate it by 90 degrees. and now the wheel is standing up the way it's supposed to be. And then when you turn it, it's going to say turn. Say it's going to turn this direction. But now if you rotate, you instantiate this on the other side of the vehicle, now it's going to be turning the wrong direction. So the reflect says, take this wheel and create it here and create another one here, but flip it around 180 degrees. So they'll both be turning the same direction is why they're doing that. And you could do all this by hand, but they've got this macro set up where it will do that for you. So you come in, you tell it that it's a left front wheel, and you tell it if you want reflected or not. And let's just go back down. Let me see where I'm.
Sounds like a lot of argy-bargy.
It is, and if you do it by hand, it gets even worse trying to figure all this out. So down here, when they said create a front wheel, they say reflect is 1 and the other one is a 1. But then when you do it on the other side, so that's the left side. If you do it on the right side, then you have to give it a -1, so that reflects the one wheel as opposed to the other one. So let me just go back and just kind of quickly whip through there. Macro. So the front wheel goes through and it says, this is something I added, this connection, because it used to have all the stuff with the shock absorbers in here. So I ripped all that out and I said, connect the steering joint directly to the chassis. So here it says the parent link is chassis and the child link is steering link. So this right here creates a connection and physically connects the wheel onto the chassis, even though there's no physical representation on the screen. Somewhere I could add a section that says visual, and I could add, if I want to create like a link arm or something, I could do that. But this connects the chassis to the steering linkage. And then this one down here, this is all still part of the same thing. So this joint called connection, it would actually be called left front connection by the time it expands this out. And then it says, here's the parent and the child. And this is the thing I'm having problems with where I try to get these numbers to come out, because they're generating these numbers. And I don't know what this stuff means, because if you go look at, we'll go to the top again here. Oh, I deleted all the comments out of this. Let's see if I can find. Anyway, at the top, since he built this on this radio controlled car, he said, one of these said, so here is, he had hex hub distance and hex hub depth and wheel travel and shock Z offset and axle length. All this has to do with something to do with the RC car. And I have no idea what a hex hub is. But he had a comment saying, oh, the hex hub is the distance from the outer edge of the wheel to the center of the wheel minus something else. And that defines as hex hub depth. And I have no idea what a hex hub is. I think it's on the RC car, that's the thing that the wheel, you know, you got a physical wheel here, and then this hub is actually bolted onto that. And then from there, it's got a link that comes out here to a U joint on the differential. So he's defining all these little pieces, and I have no idea, you know, what those names, names don't mean anything to me. But I decided to throw them out anyway. So these things where it says anything to do with the hex hub or to do with the axle length or the shock absorbers, it's still in the code here, but I just haven't thrown it out yet. And the thing was, you know, we were looking at that. Where did it go? Right about here. As I said, you tell the macro, I want to create a wheel, and you pass it if you want it to be front or back, and you tell left or right, and it defines all this stuff for you. So continue to the wheel here. That's my connection I added to hook it together. And then down here he says, here's a steering link. The steering link is another, you got links and joints. A joint is something that moves, and a link is just a physical connection. And you can do a, so the steering link, joint link. So anyway, the point is it gets complicated figuring all this crap out here. So then the next thing, here's this one says revolute, the steering joint, that you're creating a thing that, you know, it's the part of your steering that turns to make you steer. And what he did by looking at the stuff, he's got his wheel like this, and the steering, the bearing is actually right in the center of the wheel. And then he has something he calls a axle carrier. So he's got like 3 pieces all stacked right on top of each other right there. And what that means when you're done is, here's looking at the wheel from the top like this, it actually steers right down through the center like a bicycle wheel would. Whereas I want to move my my steering joint over here. So as you turn, it turns around, the wheel turns around the steering joint like this. That's not the way it is right now, but I want to experiment with that and try to get that to work. So the thing was, I was trying to read all of his cryptic things that he has here, and I couldn't make any sense out of this. So I remembered that one time you could run a command that will say, you run a Zacro command, you point to your Zacro file, and then you say output to another file. So I think they refer to it as unrolling the macro. So when we do that, so we'll come down here. So at the bottom, we no longer have the thing that says, create the 4 wheels. Now we just have a section. One section will say left front wheel and about 20 to 50 lines of code. Then it says right front wheel and 20 to 50 lines of code. Another section that says left rear wheel, and there'll be fewer lines of code because we don't have any steering involved. So this gets it all out to the point where I could play with one wheel at a time. So right here, for instance, where's this?
And watch it build it. Is that what it does?
Well, it's just you have to put these things together step by step to get them to work. And so Juan was asking, well, what software do you do to define this? Well, it turns out this is the software I'm using. It's this code right there. This XML code says create a joint in space and connect it to their thing by some distance. And that's as visual as it gets until you run it. And then when it runs, you can see it on the screen, and it'll show you, say if I define 4 wheels and then run it, then those 4 wheels show up magically on the screen where I told them to be. So the point was I had to unroll this so I could figure out, number one, how to get rid of all this hex hub nonsense and his axle carriers and all this other nonsense that was in there. So I got it down to the point where for each wheel, it would say like right here, the origin of, I'm not sure, but anyway, so it gives me an XYZ origin here. And in the macro, this is actually built from the macro. So the macro had all kinds of equations in there, and I couldn't tell what they were doing. So I could actually come in this point, and for my left rear connection, I can move these. I can just change the values for that one and just affect one wheel at a time as I play with it. So that was the trick to that. I got to the point where I expanded it all out, and then I could individually change wheel sizes, individually change the positions, and just blatantly say, put it at this position. Then when it was all done, I got your numbers and thought, okay, I'll go back and put them back in. Well, I can't do that. I could go through this unrolled version and put it all in here. Let's see, how many lines is this? The unrolled version is 373 lines, and the one with the macros in is 297. So I didn't really add a whole lot to it, but just the complexity, looking at it with the macros, that's supposed to make it easier to read, but if you don't know how it works in the first place, it just adds another layer of complication there. So the point was, after I got your numbers, I decided I couldn't put it in their thing. So I just came in here and the one with the macros, and so I just typed your numbers right in here as, you can think of that like in C, that would either be a constant or a variable. So here they're loading it in as a property, and then this becomes usable throughout the code. So I kept going back and forth until I got to the point where I'm back to the URDF with the Zacro extensions on it, and it looks like this. So it's easier to, I just change the number one time here, and then the code does whatever it wants to do with that. And I got it all put together, and it seemed to work on mine, but when I'd run yours, you got 2 wheels there, and they're supposed to rotate like this as you're driving forward or driving backward. But for some reason, they were doing like, the wheels were doing like this, and the thing was walking across the ground, and I couldn't figure out why it was doing that. And I was comparing the before and after numbers, and I finally found a number that was different. And it was one of these weird equations that I had no idea how they're calculating it. And I just blatantly stuck the same numbers in there my other one had, and that seemed to fix it. So I need to track that down. I still have more stuff I got to rip out of this to get it down to the point where it just simply says, put it on 4 wheels and make it drive. I want to get down to that point. I still need to do something about the front suspension. So either the front axle could rock back and forth like it does on a lawn tractor or a full-size tractor, or I could put the shocks back on the front and get around it that way. That would give me compliance with the ground to fix that. And then I asked the question last night, how do I add a joint and make that work? And today on Slack, one of the new guys responded and says, "Oh, I think you can just add the joint and it'll take care of itself." So I'll try that today. I'll try making a physical axle across the front and then make it pivoted in the middle. So it's just like, works just like the lawn tractors do, and see if I can get that to work. And so I've got to do that. And then there's some more stuff I got to rip out with these calculations that get it down to the point. I just say, put it here. And hopefully I can make that work.
It's a whole nother layer of complexity learning that language.
It is, and it's partly trying to learn the URDF XML format, and partly trying to learn what Gazebo wants, and then partly now I've got Zacro extensions trying to figure that out. So it gets to be a real pain trying to figure this out. But so you just go out on Google and start searching for this stuff and looking for examples, and then being able to change a line in the code and go run it again and see the model show up on the screen. That's very, very handy to be able to do that. I would have never figured this out if I didn't start with a model that runs. And that's that red car that I started with was that was the trick to the whole thing, that I had something that actually runs, and I was able to start modifying that then.
Well, thank you very much for spending time on that. That's wow. To think that it's, what was it, 300 lines of code, which is a macro in and of itself. So
yeah, so it looked like either way, whether it's a macro or not, it's around 300 lines of code. And that's after I stripped the sensors. It could be he didn't have any sensors at all in there, but he said you could add them. And so then once you start adding sensors, that's more big blocks of code that get dropped in there. I don't think you have to do a lot with them, but you have to physically put it in there for each sensor. So it gets bigger based on that. So hopefully when I get to a point here, I can go through step by step and say, okay, here, first you have to build the model. So you have to put these 4 wheels on, you have to space them like this, and let's go run it. And you can see that works. And then say, okay, now we got to control that. So he's got a Python script that accepts Ackerman commands and generates the 2 steering angles for your front wheels and generates speeds for all 4 wheels. I didn't want to power the front wheels, but when I tried to take that off, it wouldn't move. So I don't know, maybe again, it's just a matter of setting the parameters for the wheel joint. So it basically has no friction. I might be able to do that. And otherwise he's doing 4-wheel drive, and I don't really, that's just one more complication trying to figure out, the speed of the front wheels versus the speed of the back wheels. So little things like that to go through and figure out. So then my explanation would be, so you start with a model, you get the wheels, you put it on the Gazebo, it looks great. Then you go out to this Python script and you have to change some parameters in that you have to put in like the tire diameters and some other things to get it to work. So that's the second step. And then the third step would be, if you want to add sensors, then you start dragging in sensors and plop them in. So they start publishing stuff. So, hopefully it'd be nice to have something that works and then be able to go through and say, this chunk of code's doing this, and this is the steps you do, this chunk of code's doing this, and so forth. That would be, I think, a very handy and very useful thing to do.
I was just Googling the Musher platform and URDF to see if they had a URDF, but I didn't get any hits.
They do, and it took me a long time to find that, and I don't remember what it was based on. What's interesting is most of the Ackerman models you find are based on that original RC car, because I just found one last night from Olin Robotics, and they're defining like a mini tractor, like a compact utility tractor. And I was going through there, and there's the same lines of code talking about adding the batteries and the shock absorbers. So even they did a full-size vehicle, and they started with the same code. And if you go look if you search for Ross Ackerman Gazebo model, and you'll find that just time after time, people keep copying that original one and modifying it slightly. So there's tons of examples. If you try it, it won't run on your particular version of Ross, then you can find another one that will. And maybe, again, due to Gazebo version, if you pick the right ones, you might be able to get it to work that way. But anyway, I'm just going down the steps, very slowly going down the steps, trying to figure this out and make this stuff work. And I've got something that drives around, so that's a good step.
Awesome. I mean, you have the big red tire one, and you have yours, and to boot, you have, you know, the somewhat chaotic numbers that I gave you.
And when you said the big red one, actually, that's just a little RC car. It's about the size of that one you were just looking at it at Walmart. And then my mini tractor is based on the actual physical size of mine. And then you gave me your numbers. I wanted to get the point where I could take a random set of numbers from somebody's vehicle and put them in and make it build it. And that I'm close to being able to do that. So that's handy. So then Juan can say, well, he went out and measured his, and he's got slightly different numbers, but he can punch those in and define his Poland lawn tractor as opposed to his Cub Cadet lawn tractor. And I could go out and measure my John Deere lawn tractor, and they could be slightly different numbers, but each one would be fairly close to, you know, your actual vehicle at that point.
Yeah.
And then the hope is, you know, since I'm going through it's doing the full physics simulation, I can say, you know, start driving forward at this turn radius. And then the stuff coming back out of my odometry should say you are turning at this angular velocity. So, you know, just like I would do on a real vehicle, Gazebo should be close enough to allow you to do that. Whereas Stage will not. Stage, you say, start going forward and turn, and it will, but it's not giving you the benefit of having the full physics simulation in there.
Woohoo. That'd be awesome. Okay, my man. Well, I hope it doesn't snow on you.
Well, it doesn't look like it's going to snow too much. Well, I was going to pull up my Minneapolis forecast. Today's Friday. Well, I think tomorrow it says it's going to snow 2 inches, but I don't know what part of the state that's in. So
I think we're going to get some drizzle Monday. Is the first little bit of snow. So, I'm not looking forward to that. Okay, I'm gonna scoot. Thank you for.
Let me save my chat just in case. I think it does. If you don't save it yourself, I think it automatically saves it. But it's better to do it both ways, just to make sure. So, okay. So I don't think I have anything else.
Have a great weekend.
Okay.
We'll talk to you later.
Okay, bye.